Hello, this is a special episode. We've got Colin and Mike Perham here today. We were talking at San Diego RubyConf about doing something like this, and there you go. Yeah. So it probably can't see you very well in the corner here. There, we'll bump you guys up. But yeah, I'm super excited about this. We have a fun little problem that we've experienced on building Hatchbox out, where we've got SSH connections to deploy apps to servers, and net-ssh doesn't actually have timeouts for all the different things that you might want, not built in at least. So if you follow the guides and you use a connection, run a command, and loop until it's finished, that sometimes can run forever, which we've experienced. And that could be because of some random networking issue or whatever. I'm sure that people have shut down a server in the middle of us deploying to it and pulled the Ethernet cable out of their Raspberry Pi or whatever while something was going on. And I get looking into this and how do we make sure that these commands are finished within, say, 15 minutes is a maximum, which I know is against the recommendations of keeping your jobs short. But in this case, I don't know a great option to work around that. If we have to deploy code, we need a persistent connection for a few minutes. So I got looking into, as reported here, using the timeout module. Start Googling it and find out Mike has got several posts about, highly recommend not using that if you can. So what better guest to have on GoRails today?
So I say, don't use this. So now you call me in to say, okay, well,
yes.
Smart guy, how do we solve this?
Yeah.
Great. I made my own bed. Now I got to sleep in it. All right. We'll see what we can do.
So just to start off, is there any advice you'd have on a job like this that's kind of how, if we wanted to make it shorter, is there a good way of doing that? Or is, this just kind of the type of problem that can't be broken down into smaller things? Because otherwise, might have to set up the SSH connection a whole bunch of times if we're doing if we were trying to break it up. So I was just curious there if you had any thoughts on that.
Well, as the old saying goes, 9 women can't have a baby in a month, right? So sometimes you can split a process up into smaller smaller chunks that you can execute concurrently or in parallel. But other things like a deployment, first you got to do step A, then you got to do step B, and then you got to do C, and you can't do those in parallel. So it really just depends on your use case. Yeah, and it sounds like you've got something that really is serial, and it may take a little bit of time. And yeah, Sidekick is not really designed for that use case, long running tasks. Something like a rake task is probably a better idea there. But then, how do you manage the rake task, right? Yeah. The life cycle of that rake task. So, I don't know of a great solution here, unfortunately.
Yeah. And it's one where it's, you click a button in the Rails app and it needs to trigger a process to run that set of tasks. And it's it's got to run in the background somewhere. So,
Yeah. Ideally, you've got a uniqueness constraint on the job so that, one user can only have one deployment active at a time. So you don't get a flood of one person taking up all of your Sidekick threads. But,
yep.
You do what you got to do.
Yeah. So as for the timeouts, we explored a couple options. One being the obvious, Ruby's got a built-in timeout thing. We could use that. And your post on that was kind of don't kill threads with timeout unless you have to or whatever. What is the issue with that? I haven't looked into how it works, but I was curious. Is it a lot of, you didn't give the process or the thread a chance to clean up at all? It just kind of is killed as it stands, and there's no opportunity to do the safe things? Or
yeah, the problem is timeout is kind of like kill -9 for a thread. you can interrupt a thread right during like an ensure block when it's trying to clean up a resource, and you can therefore leak that resource. It happens with connections in a connection pool if you're not really careful. Um,
Yeah.
so unfortunately, Ruby has APIs. Thread handle interrupt is a really kind of weird, obscure API that's meant to try and work around some of this, but it's one of those issues where it's just never really truly safe. A safe operation. It's really only a last resort. So if you can, you build in proper timeouts, proper socket timeouts. Those are demonstrably safe because they only operate at an individual socket level and not like all of the thread and all of the resources that thread is holding.
Yeah. Yeah, that was pretty much our, and this was a hard one to debug because locally we can't seem to reproduce. Like if we have a command that we want to kill, we've got a solution for it, but then occasionally something else happens in production that we can't reproduce locally. So as part of this, somebody had this example using timeout to basically you set up the SSH connection, you open a channel to execute commands, and then you have to use the loop, which will wait for the command to finish, and the SSH connection is kind of like not doing anything, and then that will finish, and you can go on from there or whatever. So we ended up with a solution for this the loop takes an argument and will check in with this proc that you give it or block every 1 second or every 10th of a second or something. So we ended up with this timeout where you can set your timeout, and then we look at the monotonic time, which, do you have a good explanation of what monotonic time is?
Yeah, so monotonic time, that monotonic clock is meant to be a clock which never returns a value less than the previous value it gave out. Like as time passes, the value it returns will always be increasing.
That
And
is
that is
something you may
that
not
is
think of
different.
either.
That is different from a normal clock, which due to like leap seconds and clock adjustments can actually go backwards. Like, say, for instance, daylight savings time, right?
Yeah.
Where, the clock can either jump forward or jump back. The monotonic clock never jumps. What it does is smear over time. So if you're bumping back a second, it will actually just slow the clock down so it's not returning increasing numbers as fast until it
Oh,
catches up
really?
to what wall
Oh,
time is. And then likewise, if the clock is jumping forward, it can obviously do that because that's an increasing number. But the idea is that you can always be sure that time B is going to be greater than time A, always.
interesting. Because, yeah, I mean, that's something that until I think this post here, I had never really heard of monotonic time. I wasn't really doing anything that needed that sort of precision. And if you're not thinking about it, you would just say time.current minus whatever the time was when you use the Rails helpers and stuff, and you'd be fine most of the time. But there would be situations that would be impossibly hard to detect unless there was like a leap year or some clock adjustment, or something
Right.
that happens.
So
Then
think about so those two lines you have there that are just about scrolling off the screen there.
the ones
Um,
up here.
yeah, right there. So think about if you get that timeout with the wall clock, and
Hmm.
then all of a sudden daylight savings hits and the clock goes back an hour, then your check here will allow the process to run for an hour and 5 seconds,
Yeah.
right? Whereas monotonic time, it will always return a value that you expect so that that loop will only iterate for 5 seconds before it times out.
That alone is really interesting to know. And I think there are a couple other options when I was looking into it. I forget what they were called.
Yeah, there's definitely
Um,
a few other ones.
Yeah. Oops.
It's funny, like I knew this existed here, but I'm like, I don't know when I would ever use that. So like this is great.
Yeah. Oh yeah, real time,
Yep.
monotonic, real time fast, coarse, precise. It's interesting. There's a whole bunch of different ones. Time is obviously a very complex thing. And I believe monotonic is typically kind of since your computer booted, because you don't necessarily care what the exact time is. You just
Right.
care that it is increasing, and you can do the difference between them. It's like
Yeah,
the
it's meant for
duration is what
relative
matters.
operations. Yeah.
Yeah. That was super cool to find out, because I was like, what the heck is this number? Can I even convert that to like a date time? And it's like, well, not really, unless you know the exact time your computer booted and had that as well. You could do that and add them together or whatever, but you don't really care in this case, where you're just like, hey, whatever time it started, I want to set our deadline timeout of then plus 5 seconds, and that works super well. Um, that was super cool. I thought that was good. And so getting to debugging this in production was kind of interesting. So yesterday we had one of the threads that was running one of these jobs that had run for like 6 days, and it was supposed to be killed after 15 minutes. As I got looking into it, so I used GDB. We've talked earlier about being puts debuggers, but that's a hard thing to do in production when you've got all these threads running, doing different things. I don't know what state they're in. I can't reproduce this issue locally, whatever. So I got into looking at GDB, which allows you to connect to a process on Linux, and you're able to actually access the threads, and you can call the C code to print out, for example, the Ruby backtrace into standard error or standard out, whatever it is set up to do, probably standard error. But it ends up printing out in like your logs of your Rails app. So I captured these, and we could see that the code ended up in the backtrace where it's done the connection to the server and is saying, hey, let's go clean up all the connections to the different servers, go through each one of those and close the SSH connection. At which point it goes into this event loop in the net-ssh library and just runs forever. So this was the line of code that stuff was related to. And if we pull that up here in net-ssh's source, line 125 is where we go to close the SSH connection. And this is where it does a loop and just checks to see if there are any channels still open. So the SSH connection can be multiplexed with several things going on at once. And this line just before it tells them all, flags them all to say, hey, it's time to clean up. But it's just like a safe, let them know, and then we will wait until they're all cleaned up. So somewhere in here, one of these channels is misbehaving and never actually cleans up. But the close does not have a timeout on it, where this stuff we had added to the execution of a command across the connection. What we didn't realize was when we go to close the connection, we might have killed the command and stopped it after the timeout of 15 minutes or whatever, or in this case, the 5 seconds. But this was only applied to the commands we were executing, and we didn't realize that the cleanup code for closing the connection safely also needed a timeout. So we were able to see that here, where it's like, oh, our thread is hanging at a point not in the execution of stuff, but it's actually hanging at the closing of the connection. So yeah, this is where we kind of landed. Like, we need to basically go, ideally patch net-ssh to include a timeout here, which I think can be basically the same implementation pretty much as our execution of the commands across the SSH connection.
You just don't want to make another 15-minute timeout here, right?
No, this one should be much shorter, right?
Yeah, I would think so.
For example, the commands that we were running for deployment might be Webpacker, and depending on the amount of assets you have and the size of your server, we definitely had people running the Webpack build step and it taking over 15 minutes because it was just chewing away at their $5, CPU, trying to compile JavaScript and transpile and do the assets and all that stuff. But when we come to the point of like shutting down the connection, yeah, this should be a short timeout.
I was going to ask, whenever I'm trying to solve this sort of problem, one of the things I try to think about is, am I hiding the pain? And what I mean by that is applications, when they have bugs in them, that's a form of pain, and the buggy behavior is that pain surfacing. And you want developers to feel a little bit of that pain so that they have a reason to fix the bug, right?
Mm-hmm.
If we're putting in this timeout and we're sort of papering over the underlying issue, that causes me a little bit of worry. So are we hiding the user's bugs here by killing off, long running SSH commands? And should we be doing anything to notify the user, hey, we had to kill your connection because it took too long. You should spend some time trying to optimize this to run faster or whatever. So, what do you think about that?
Definitely agree. So we have it set up for a couple different ways in the Hatchbox. One is that when we execute a command, we capture the standard out and standard error, but we also capture the exit code. So we know if you ran Rails DB migrate and it returned a non-zero exit code, you have a command that failed. And we can tell you this command failed. It might be, oftentimes we see this where you will have run bundle on your MacBook on Apple Silicon, and you go to deploy to Linux, and it's like, hey, bundler does not know this platform, and you need to add the Linux AMD 64 platform or something to your bundle lock file. So we have that as one thing. And then we also raise, when we're executing the commands, we raise a different error that is like command timed out when we hit that 15-minute limit for the commands themselves. So here, we should be either safely closing the connection or we're not using this as the timeout for the commands basically, or we would want to raise a specific error in this case and maybe ensure that we always call, say, this transport shutdown at the end here if it raised an error or something, because that's a very good point. The multiple ways things can fail, you don't want to rescue all of them and treat them all the same because they should be handled differently. Or if you don't do that, you have no way of knowing that they're separate problems that could be handled separately, which I think is a good point too.
Is there any chance that so there's a couple things here. The SSH on the local side is getting terminated, right? We're killing it off so that the connection to the remote machine just dies. Now, the thing running on the remote machine, is that actually getting cleaned up, or is that still going to run forever?
That's a good question. And
because those are resources that are presumably being billed per second, right, on AWS or whatever.
Yeah, it's an open socket SSH connection that probably is handled with keep alives. And actually, the net-ssh stuff does implement keep alives to make sure that the connection does stay open. I still haven't quite exactly figured out, what is hanging at this point, because it goes into the session lines 179 and 226. So down here is where it goes into the loop. And then if you give it that little wait, it will evaluate the block. every 0.1 seconds or whatever. But then it goes into process, which was, I think, that 226, where it starts dropping down into the actual socket connection stuff. So event loop lines 30 and 11. Where'd my mouse go? There it is. Was that under connection? Yes, connection, event loop. 11. Maybe I'm on a different, I think I'm on my other branch that we're using. Where was that? Jump proxy keys. This might be a little different. Nope. Well, let's see here. EV select and post process wait. So this is some of the underlying code that actually is handling the connection, I guess, which I haven't actually looked in myself. So it gets kind of way low level at that point of.
Yeah, I mean, IO select, I think, can take a timeout.
Oh, does it? Yeah.
I mean, IO select is going to be the lowest level, just fundamental API call where things are blocked. So that's what I would look at putting a timeout on, because that'll time out like literally everything.
Mm-hmm. Yeah, I'll have to look into that, because that could be harder to set up, where you'll have to initialize your event loop with that, or pass this in as we have a wait and maybe we need to add a timeout to that, so it affects the event loop class and the connection or the session there as well, higher level, to make sure that that is handled accordingly and stuff. But that does make sense to sort of drop down further in there. And I'm also kind of curious, the harder thing to debug too is like, what is the state of the SSH connection, and why are these channels why are they still hanging? Why do they think something's still going on? And that's also the other hard thing, is like, every time I test it locally, pretty much just works fine. So it seems to be kind of a much tougher thing to go debug for some of that, because it's not easily reproducible so far. But if I could reproduce it, that would probably be worth.
There's two types of timeouts that we need to be wary of. The first timeout is just individual characters, right? Is the thing sending anything at all? And then there's also a higher level timeout of like, we want this SSH operation to take less than 10 minutes. And it may pump megabytes of data back and forth. But if after 10 minutes it's still running, we want to kill it, right?
Yeah.
So there's the individual IO timeout, but then there's the broader sort of idea of an operation timeout.
Yeah, that's a good distinction to make. I think in here in channel was where we were talking about earlier that the session itself was when we closed. Let's go back to session, and we called close. It goes through and marks each of these channels to be closed. And so that just was an interesting method of setting a Boolean to tell it to, here it is. The close method just says, okay, if it's already closing, then great, mark it as closing, just so internally, as this channel is processing whatever it's doing, it knows, hey, we should get ready for closing. And what's nice too is there's a lot of decent documentation through here that will tell you, hey, go read this other method. As we noticed earlier, like, there are places that it helps you navigate all the different organization of the objects and stuff, which can be one of the hardest parts of trying to debug brand new code you've never seen like this before. Like, what is a session? What is a channel? What are these abstractions, and why do we have them? Because this gets a little bit into kind of what you're talking about, is like the local and the remote side of things is that one still trying to talk? How can we tell it to, hey, slow down, stop, we're done here. We don't need you to keep sending data. And maybe that's one of the things that's happening right then, is like it just keeps talking. And we've in our example here, we're looping through the connection, but maybe what's going on is this has told it to execute a command, and it's just doing its job. It could be running for 30 minutes or something, but we've just stopped listening at this point on our loop. We've just said, hey, we don't want to hear this anymore. And that could be the thing that's like, we need to have some way to interrupt it or cause it to shut down remotely. And I don't know a ton about the SSH protocol on how that stuff works. If we need to send a command or something at that point, maybe that is where we need to know, is it past the maximum time or the deadline? And maybe there's something we can tell the remote server that, hey, you better like stop your command and kill it or whatever.
Yeah, generally the remote process, if it's piping its output to that SSH network connection so that you can see it locally, and you close that network connection, then the process will die when it next outputs to that network stream, because the stream's been closed. And so you'll get an connection reset, I think, maybe. But if that remote process is not actually generating any output and it's not using the network connection, it'll continue churning along forever.
Because
right?
It's not
as long as
error.
it's not outputting anything, it's not going to get an error. It'll just continue calculating because it's not looking at the SSH connection. So that's the other thing is this 4-day process that you're talking about here. If it's not generating any output, it could run forever.
And
that's why it's probably beneficial to run these scripts in a wrapper process that just wraps that execution process with a timeout. And after so many minutes, it'll just kill that child process that's actually executing. That's the only, to me, I don't know of any other surefire way of actually ensuring that a remote thing shuts down, except to run something locally on that machine that kills it after so many minutes or hours or whatever.
Yeah, and that was something we looked at too, like the where is it? There. Whoa. We could prefix commands with the Linux timeout command, which is kind of I guess that's probably how it's implemented, where basically run a timeout for 5 seconds, run this command, and kill it after that. So I assume it kicks off the command, records the PID, and then knows to send a signal to that command after 5 seconds or however much time. And then maybe it's, does the interrupt or one of the safer ones. And then if it doesn't respond after a little bit more time, maybe it does a sig kill or something. But
it looks like if you scroll down, it tells you. So right there, it says sends the term signal.
Sig term. Yep.
And then
so maybe they don't respond properly to sig term, and you might need to use something more aggressive like sig kill or whatever.
Well, and that's what the next section talks about, -K.
Yeah. And this is, and that's cool too, preserve the status. So the status of the command that you get back, you can have timeout still return the same thing. Because if
I would say your SSH runner needs to use this timeout thing, run it in the foreground, and use the -K to ensure that it dies. But I mean, if I was running something like Hatchbox, where user deploy scripts are running on these machines, I would definitely be wrapping it in this timeout thing.
Yeah, because there are, there are times when you might want your own custom deployment steps that are, install this library or make sure it's installed and then run db migrate and stuff like that. And in those cases, that's like a bash script we'll upload and execute. And we could just prefix that with a timeout of 15 minutes. And that would be probably would take care of most of those situations, because you wouldn't have any rogue things going on with the SSH connection running those custom commands directly. In that case, you would assume, and timeout is probably simple and battle tested enough of a process that that command is going to be reliable, very reliable.
And it's doing the standard Linux shutdown process, which is send a sig term, wait a few seconds, and then sig kill. Right. Mm-hmm. That's exactly what Sidekick basically does too.
Yeah. I remember that was and that's when we deploy and we see Sidekick taking a while. It's usually because there's a deploy that was stuck for 6 days or something, and then it takes that time between it still hasn't shut down yet, and then it kills it. And
right.
So yeah, that's definitely been an interesting thing. One of the really cool things you pointed out, so when I was getting this backtrace from our live Sidekick process that was running, you pointed out that you can send the TTIN signal and effectively do that without having to go through the weeds in GDB and figuring out exactly which thread you want to grab and all of that stuff. You want to talk a little bit about that? Because I didn't know about this, and I'm sure I've seen the signals page before, but didn't realize this was the thing that I could have saved a ton of time doing.
Yeah, well, it's hard to debug something like Sidekick when it's multi-process or multi-threaded, and you've got a lot of stuff going on. But the one tool that I can provide is this TTIN signal. I say it's short for thread information, but it's some arcane Unix signal that I just reappropriated for this purpose. But yeah, as you say, Sidekick may have, let's say, 5 or 10 jobs executing at once on different threads. If you send the TTIN signal, it'll dump to the log file the backtraces of all those different threads. And that can be really helpful to find a particular job that's executing and it appears to be stuck, and you just don't know where it's stuck or why it's not finishing. So then you can actually see that thread and the backtrace for that thread, so you can see exactly where it is stuck. It is extremely useful. Now, on some platforms like JRuby or Heroku, you don't have direct access to send signals to Sidekick, but instead, Sidekick also provides an API that you can use to send this signal to the process. And that's built in, that's documented on the API page there. If you search for dump threads or just dump, it'll show you the process set. The process set is the set of all Sidekick processes that are using the given Redis instance that we're talking to. And so for each process, you can go through and send it the dump threads, call the dump threads API. And that asynchronously tells Sidekick to dump its own threads. So it'll happen within the next 5 seconds. Unfortunately, it's not real time.
But it doesn't, if that thing was stuck or whatever.
But if it's stuck, exactly, the timing's not super important.
Yeah, I was going to say the same.
But yeah, you can use this API to do things like during deploys. You could quiet all of your Sidekick processes just through one line of Ruby code, and right as you start the deploy, and that way you're giving your jobs more time to finish before you actually have to stop Sidekick.
Yeah, that's a really good use case for that too, because you want, and even if those have a little extra latency of being processed, you want them probably anything new coming in to run against the new code, after the deploy is finished there. And your deployments probably aren't that long unless you're still on Webpacker and running on a $5 server.
I don't mandate this because you're right. Every deployment situation is different, but yeah, if you can quiet your Sidekick processes for a minute or two while the deploy is running, then that just gives your jobs more time to finish up and gives you greater certainty that your Sidekick is going to shut down immediately when you tell it to stop because all the jobs are finished.
Yeah, because you don't want to kill a job in the middle of it being processed. I mean, in theory, you should be writing your jobs that are. Well, Amanda just tweeted.
Oh yeah, there it is.
Item
Come
potency.
on. Yeah, there it is.
Was mentioned in the Rails guide somewhere, and it was like, if you never heard that term before, you have to go look it up and try and understand what does that mean. And so I hope they keep the term in the guides because it's important because you will see that mentioned a bunch of places. But it's also like nice to have the layman's terms of this should be safely retriable or something, that sort of describes the important thing there.
Mhm.
But
Yeah, I think I was gonna say I think Xavier had a good example there of like load versus require in Ruby, right? You can just require will hit the one time, and you can call it as many times as you want after that, and it's not gonna reload that file versus load.
Yeah.
Item potency is one of those concepts that you can't paper over, right? It's just a fundamental thing that as a software engineer, you really need to understand. And if you don't build your jobs to be item potent, then you're going to have bad time. You're going to have subtle bugs. You're going to have data inconsistency issues over the long term.
Sure. Yeah.
Well, it's even something you want to do in just general code as much as you can too, where it's like, calling this thing twice. And if it has side effects by doing it twice on accident, that's probably not what you should be doing. And even we can look at that one little example here of close. Like if it's already closing, we don't need to do anything. We just say, cool, thanks. We already got, we're already good. Like in this case, there's no side effects if it set it to closing twice or whatever, but it's a good example of like how you could implement something that's got a guard at the beginning that says like, cool, yep, we already know, we're already on it. Like require does, don't load twice. Were there any other of these signals that you wanted to point out here that are interesting or related?
You mentioned RB backtrace in the problems and troubleshooting wiki page. I do have a note about that. Using that with Sidekick.
And I will shout out a couple of these blog posts about using GDB. They weren't exactly all functional because I had to add the return value when you called that. Where was it? The RB backtrace. This one was the one that was actually correct. You had to add the void in there.
Void. Yeah.
But it was cool. You run it as well, and you see the example here, but it's like you will just get the GDB prompt right afterwards as if nothing happened, but the logs are actually written to the, Rails logs or whatever. So that was kind of confusing at first as well. But which page did you say?
Problems and troubleshooting. Just search for problems. Yeah. So search for RB backtrace. So right there.
Yes.
So if you look at the whole question there, I basically tell you, oh, here's how to get all the threads or whatever. So how to debug a frozen process. Yeah.
Yes. Yeah, that was a very interesting, fun thing, but without knowing, much of the C source code of Ruby, it can be quite a daunting thing. Especially, you look at the blog post here, and it's like eval commands, okay, understandable, but you get down here, and it's like all the C code and type defs and whatnot, and it's like, okay, we're far from Ruby territory here.
Pretty overwhelming.
Yeah.
But you notice if you look at this question that we're looking at right now, go up to the top of the question where the answer starts. It basically says, send it the TTIN signal. It tells you most commonly a remote network call is hanging. I mean, it's basically saying exactly the symptoms you're seeing and how to solve it. So
Yeah.
what's old is new again.
Yes. No, this is great. And it's funny too, because you will, depending on the words you search on Google or at GitHub or whatever, will land you here, hopefully. But sometimes you will not type the word frozen process and be like, I'll be searching for a hung net-ssh connection or something and go down a different rabbit hole. But using the right terms can sometimes, we could have found out this way sooner.
Mm-hmm. Yep.
Yeah. Yeah, it's interesting to get into some of the weeds on these things because like typically we are doing Rails applications. We're so far away from the actual database connections and all of that most of the time. We're using the results of that. Active Record is taking care of that. Sidekick's the one talking to Redis. We don't do much of that. We're at a higher level of abstraction. So when we come and see these kind of issues and realize like, we do probably need to implement a timeout on close just to make sure that, hey, we intend to close the session as gracefully as we can, but if that doesn't work out and there's something underlying that's going wrong, let's kill it. They feel very daunting. Like a few years ago, I probably wouldn't have had any idea on how to solve this at all because I'd just be like, how many Rails developers probably have opened a socket themselves and connected to a service? Like I did this a long time ago, writing my own IRC client. And I was like, I don't know how the protocols work. So I'm going to go do that myself and see how it works. And I open a socket, connect to what's Freenode, the biggest IRC server or whatever. And I connected and I got a message back and I was like, this is so cool. And then they send a ping and I'm like, oh no, I didn't program the Pong. And then I get disconnected after a couple seconds. And I was like, crap, But then as it turns out, that was one of the coolest projects I ever did because that was in Python. And I'm getting the messages back over IRC and they all start with the command like ping and pong and whatever, direct messages and channels and stuff. And I was like, why can't I just let me trim off the first word of every message I get and call a function with the same name. And I'm trying to do that in Python. And I got this giant if statement of if the string is this, call connect or ping or pong or whatever. And then I was like, maybe there's a way to take a string and call a method with the same name. And I'm like inventing metaprogramming because I don't know that's a thing yet. And then later on, I learned Rails and I read the metaprogramming Ruby book. And I'm like, mind blown. Like, this is amazing. But that was like not typically a thing that you would do in Python at all. So it was very interesting to like discover that on accident and then come to Ruby and be like, this is just a thing we appreciate here as a possibility. Like we kind of, allow that instead of sort of shun that like other languages might want to do or whatever.
It's a form of dynamic dispatch. Yeah.
Yeah.
Ruby's high-level dynamic nature allows you to do that. You can just send a method.
Yeah. Which is kind of the whole object-oriented send a message,
Indeed.
Philosophy.
So do you want to write a fix to close here, or what do you want to do?
I would love to see what you would do to, like, if we wanted to just, we don't need to build an actual example, but if we wanted to take, I guess, close, or maybe you would implement it somewhere else. But if you wanted to just kind of sketch out what a solution for this might look like, that would be really fun to do.
Yeah, well, like I said, there's the two levels of timeouts. Do you want to add a low-level timeout to that IO select, Or do you want to? I mean, obviously, the problem at hand here is more of the higher level timeout that
Yes.
this loop suffers from. So
I
let's
mean,
focus on the problem at hand there.
okay. I was going to say that's a good question though of because we don't necessarily know the IO timeout or the event loop portion that is being called dynamically through these things. So it may be too simple or not knowledgeable enough of the overall
Yeah,
thing to like it might take a lot of work to go and implement a timeout at that level. So this is probably the place to go. But it's important to like think about that on what's the best solution for this. Long term, that might be better, but might require rewriting some major chunks, in which case is also a little bit dangerous because then we end up with our own bigger fork of net-ssh that is going to be harder to pull in any major changes that they might do in the future. And that's been sort of the, thing over time with any project is you depend on someone else's code, but it's yours now. Like,
yeah.
if it's not working the way you need it to, then you've got to change it. And so in this case, trying to keep it as close to the original as possible. And hopefully this could be a pull request we send back. Because I did have something for doing, we were in one of the tabs, the jump proxy branch, which was like the jump proxy functionality didn't actually retain the same like SSH keys that you could provide to the initial connection or something. So I had a patch for that they merged a while back that was like, hey, if we give you SSH keys and you need to jump to one server and then SSH into the final server, we want to use the same credentials through that process or whatever.
Right.
Right. And that was something that didn't work before, but they, graciously accepted a patch for that.
Okay.
So I believe I have net-ssh pulled up here. Are you a Vim user?
I've switched over to VS Code.
Okay. We're in VS Code, but I do have Vim shortcuts
Yeah.
on. So I didn't know if
I
that
use the
was...
Vim shortcuts also. I feel bad because I wish there was a Vim that I could use. I feel bad using a VS Code, owned by Microsoft. I feel like I should be using an open source tool and not a proprietary tool, but
Yep.
it is what it is.
I have come to enjoy VS Code for the ease of use for beginners because of the dev container stuff that they have where it's like you can just pick up a Docker image, edit inside of there, and you could be on Windows, you could be on, GitHub code spaces, whatever. It's kind of nice. Like it seems, but I do have this piped out to NeoVim for doing the Vim commands because it wasn't as, their built-in stuff is not as compatible as I would like. But anyways.
So if I were building this fix, I would monkey patch this close method. Like I would put an initializer in my Rails app or in my whatever your deployment code is to just monkey patch this one method, and that way we're not having to edit the gem. Instead, you're using the release gem with one method monkey patched, and then you can use that for testing. And then if you do want to send a PR, you can obviously roll that back into the main branch.
Yeah, because if
it looks like you're gonna edit it directly.
I already had the code here, and for the most part, I figured if we needed to look into any other files or whatever, it might be easier. But when you would do that, would you reopen the class directly and add your patch to it, or would you write it in a module and then like prepend the module or include that in the class? I was just kind of curious.
No, I would reopen the class. I wouldn't do a separate module. I just monkey patch the thing directly.
Yeah. I think that's usually what I've done. But then with Rails having the like to prepare blocks, I've started I could just add a module and have the to prepare block just include this which would override the function or whatever, inject something new. But I think that's probably the easier path for just a basic, thing because also this does not have a reloading feature like Rails would with your models and Active Record or any of the other libraries. So it's one application of this is just all that will ever actually run instead of Rails in development, like reloading your classes and things.
Right. Yeah, I wouldn't be monkey patching any Rails application code. It's only the library code where you just want to change this one method for one very specific reason all the time.
If you want to dig in, we're on tuple, so you can start typing here if you want, or you can tell me what you want to do here. My guess would be
let's talk about what the implementation's looking like. So we basically want to put a deadline on this close, right?
Yes.
So when this method is called, we want it to return within, what's our time limit and how do we get that time limit?
Mm-hmm.
So should we pass in like a keyword argument to this method, or should we just have like a global?
That's a good question. I would imagine you would want to potentially control this a bit. Maybe in certain cases you want a longer timeout. I'm not sure. In general, I guess on the close you probably want a consistent timeout. A global would work.
Close seems like it should finish pretty quick. Yeah. It's not something you want to wait for 10 minutes or 20 minutes to finish.
Right.
So should we just put like a 30 second?
I can't really think of situations where you might want to close in 2 seconds in some cases and 10 seconds in others. It's probably, but having as a keyword argument gives you the option to do that. So if you said timeout of 10 seconds, even 10's probably a little long. In theory, the cleanup of these should be pretty quick. But
yeah. I think 10 seconds is as good as any value.
Good default. Yep.
Yeah.
Okay. So if we start there, we don't really need to modify any of these places because this is queuing up the graceful shutdown as best it can. So really where we want to focus on is here, but we need to calculate that deadline, as you were saying. Is that something you would do first before you initiate the closing of the channels, or do that afterwards, or what are you thinking? Because this really just doesn't do any actual work itself. So if maybe there was, if that actually did some stuff other than just setting a variable of true, maybe you would want to calculate the deadline before I think
the deadline is for the entire method. So the deadline should be calculated as the first thing in the method. Yeah. And then everything below that needs to finish within the deadline.
That makes sense.
Monotonic clock plus timeout.
Yep. Which was, I'll go grab that reference over here.
Process monotonic, clock monotonic, yeah.
Yeah.
Yeah, that's exactly the right. Yeah.
Cool. And then
inside the loop point 1, you would just say if the clock is greater than the deadline.
Whoa.
Or
and we would do channels any, or let's see.
I think and
it's less than the deadline.
Clock is less than the deadline.
And basically we just need to grab the current monotonic clock time again to do that. Let's make this a holy moly. Something like that. So you keep it all in one line.
I think that's effectively what you want.
And then this will stop looping and then it will call the transport close. Is there a risk then potentially that we break out of the loop and the channels are still considered active and not closed? Then potentially you get into the issue of like transport close maybe is also waiting for something or whatever. Is there a point where you would say raise an exception if this is past or at the deadline, and then have a rescue or insurer that would call, say, that transport shutdown to make sure that it did a hard shutdown? Is that something you would consider?
Obviously, it depends on the complexity and the correctness of what you want to do here. If you truly want to make that deadline an actual real, guarantee, then you might need to wrap this whole method implementation in timeout, right? And it'll run it in a separate thread, which after 10 seconds, that thread will just get an error raised in it. And so that makes sure that everything happens within that 10-second timeout. Here, we're just making sure that this loop doesn't go more than 10 seconds, but we're not putting any constraints on the various close calls.
Yeah.
So I don't know what the right answer here is.
It seems like this was the main issue, but potentially if we rolled that out and it ended up hanging inside of transport close instead, then we would know. But right now we saw that it was stuck here on the loop because there was always a channel that was active.
Do we know what transport close does internally?
I saw it earlier. I think transport session had close in here. Cleans up the socket and closes the socket. And then that's where we saw the packet stream cleanup. So if we go to packet stream, cleans up the client and the server. State cleanup. This is, some of the fun of digging into code and seeing the layers of things.
Yikes.
Cleanup.
Just cleanups all the way down.
Yeah. So the state compressor, decompressor, air compressor. That's interesting. It doesn't seem like, well, I don't know what the compressors do, but it goes off to finish a compressor and close that. Does it say? Not really. Where is the compressor stuff? Wonder if if it references classes for that. zlib inflate, zlib deflate.
Yeah. They're just cleaning up zlib handles.
Yeah.
Which I think is necessary, but I don't think entails any network sort of traffic. So I think it looks pretty safe to do without having,
if you were to
dived any deeper. But
yeah, like this should be, chances are this is good enough that we mostly say, hey, the channel's something stuck there. Maybe one is running and just not outputting anything, hasn't shut down the connection. And so we are at that point where we want to just trust the rest of this doesn't need to be killed as well. But maybe there's a situation for that. But also you wouldn't want something like if zlib was writing to a temp file or something, you would want to make sure that it is safely cleaning up any of that stuff if it's doing that. I don't know that it is, but if for some reason it was packing stuff and unpacking and temp.
You want to make sure that stream is cleanly disconnected and closed.
You don't end up with a bunch of temp files that, could fill up your disk or something. You'd rather clean them up right now instead of later by the OS.
I do want to point out one sort of semantic here. If we do pass the timeout, if we do pass the deadline, and not all the channels have been closed, then we get down into. No, I'm sorry. We don't raise SSH disconnect. No, I'm not sure who does that. Does channels any raise that? Or maybe the loop does?
I'm not sure.
Just wondering how we get to line 131.
Yeah. And I wonder if we can find where that is raised.
I'm guessing, yeah, probably somewhere in channels any or. Yeah, I don't know.
You raise in the packet stream. So,
so is that connection reset?
Packet.
Yeah.
Yeah, connection
closed.
By remote host. And that one re-raises the error, so it wouldn't have even reached transport.close if it was disconnected. So it wouldn't have even called this because this isn't in an ensure block or anything.
Sure. Yeah,
so
right.
that re-raises, it wouldn't even clean that up.
Yeah, that's one case where maybe we want the ensure. We want to put that transport close in an ensure block.
Mm-hmm.
The other question is if we're closing this stream, why are we raising a disconnect error in the first place? We want it to just go away. Is it really harming anybody to just swallow this error?
It's true. Yeah. I'd be curious to see the Git history on that and if there was a reason for that, because it's not documented for anything.
I mean, I guess you don't, if the two sides aren't communicating the proper protocol back and forth to like shut down cleanly and correctly, then I can see wanting to raise that error because you've got something to fix.
Yep. It seems like that's probably why that's in there. It's somebody was abusing the protocol a little bit during closing.
The remote side didn't cleanly shut down.
Yeah. So it makes sense. And I would assume that a library like this, same as building something like Rack, you want to follow the protocol and all of the nuances to it and be as standard as you can be with that. Like, someone didn't cleanly do something in this case. We should raise an error because technically it wasn't done properly. But to your point of our perspective on it is we don't care. We were trying to close anyways. So at a higher level, you might put that abstraction over there and swallow those errors and say, okay, whatever. We don't care. We were trying to close the connection anyways, and that's fine. So, but this does allude to the cleanup of the transport with zlib and anything else there being safe because they're not cleaning it up. It would already be in an ensure block if they were, absolutely needed to safely clean those up and handle any file descriptors or whatever is open for any of that stuff. So, yeah.
If you think about it, this whole begin rescue block is really just notifying the remote side that we're going away and just giving the remote side time to respond. Because otherwise you could just do 124 and then 133 and you're done, right?
Mm-hmm. Yeah. Yeah, and I wonder doing the channel close, seeing, it sets this true variable. Where is that used? How does it know when it's closing? And what does it do there? Could be interesting to look at as well. Channel. So closing, end of file, sent end of file, local closed, remote closed. So all those seem to be ways of closing or denoting that your channel is closing. closing question mark is not used anywhere in this file though. So maybe that goes back to connection though. So or the session closing. Really see what the channel closing Boolean does at a quick glance. But there's probably lots of this, which is a very well documented library, having all this kind of information about SSH is complex. There's a lot to doing all these different things you can do with it.
Look at the second paragraph. This will raise an exception if the channel has been, I can't read that because it has been previously declared
that no more data
In other words, if you close a channel and then you try and send data on it, the send data will raise an error because it's already been closed.
Yeah, if it's this end of file. But I didn't see much that used closing. Oh, here we go. Process. Aha. If an on-process handler has been set up, this will cause it to be invoked, passing the channel itself as an argument. So that's that little callback thing. And then if it's closing and not local closed and output is empty, and remote ID, send a channel close byte. Local closed is true, cleanup self. Interesting. So the next process, which is probably what happens when you're doing your SSH loop, it's going through all the channels that are being processed, calls that to do whatever its thing is, grab another set of data from the connection, and then that sort of tells it, hey, we need to clean up and shut down.
Yeah, in effect, it looks like this method is called on every tick of the event loop where this channel has something to process. It'll call the callback, and then once your callback's done, then it checks, oh, have I been marked as closing? Have I sent all the data to the remote side? And if so, then I can actually shut down the channel.
Cool. Yeah.
And that byte that it's sending is the correct way to shut down an SSH connection, right? So you have to inform the remote side that you're going away.
Maybe up here at the top. Nope. Packet.rb, register channel close, local ID long, constants.rb, 97. Interesting. So you'd probably be able to read up on the channel bytes and stuff like that through, the docs on the SSH protocol. And
this is the SSH protocol, the low-level details of it.
Yeah, that's cool. We don't usually, in our day-to-day stuff, ever go that far down, but sometimes you might need to.
I mean, we did go on that sea excursion at one time for a couple hours.
Oh, yeah. That was also thanks to Mike. One time we deployed GoRails with a new version of Ruby, and it started segfaulting. Like, it compiled fine for some reason, and then it would segfault in production around OpenSSL. It turned out that our server was so old on DigitalOcean that they had it where it would manually pick a kernel, and we had upgraded the OS several times or whatever, and it was still running this old kernel, and it didn't detect and automatically use the latest one that was installed like they currently do on new servers. So it was like grandfathered into some old configuration thing. So we get debugging stuff that day, and it's like this obscure thing with OpenSSL, and we're Googling and trying to figure out what in the heck is going on. And we come across somebody had opened an issue on Sidekick, similar thing, same kind of error message or whatever, and you had posted like, sounds like something's totally screwed up with your operating system. And and we were like, crap.
Good luck, sucker.
Yeah. So we were like, oh, this is bad. And we ended up writing a teeny tiny C program to like use OpenSSL for some, just to like compile against it basically. And that seg faulted as well, just like Ruby did. And we're like, oh, that's a problem. And then eventually stumbled on someone else reporting that issue to like DigitalOcean's forums, and it was like, looks like you're on like Linux kernel 3, but you're on, you should be on Linux kernel 5 or 6 or whatever by now. And sure enough, go into the settings in DigitalOcean, which none of my other servers had because they were all newer, and it was apparently just some old legacy thing. So yeah, we were on a wild goose chase that day trying to figure that out.
Yeah, sometimes production bugs come down to simply, what haven't I upgraded in a while?
Yeah, or what have I upgraded recently?
That too. It's either change or lack of a change that generally causes bugs.
Yeah. Yeah, it was funny because it was both. It was, we upgraded Ruby and then haven't upgraded
the other
kernel.
Yeah.
But you run the like apt upgrade command and it says it's installing the new kernel, and you assume that it's going to use the new kernel, but even with the reboot, it did not. So that was a very wild goose chase. But it felt like similar to if you have to get into GDB to debug something in your Ruby programs, you were way down there into some very obscure stuff that hopefully the language of Ruby protects you from 99% of the time from having to do that. But it's also awesome to have things like the TTIN signal that you've implemented to say, hey, I'm going to save you from having the trouble of doing that. We can just let you get the output without having to, even leave the Rails console or whatever. Like, you could use the API to do that. So that's super handy. The implementation of that, I'm curious. That's probably just a trap in Sidekick of the TTIN. I did a video on signals for Go Rails a little while back, but it's always fun to see how that's done in a library as well.
Yeah, jump into CLI.
CLI.
.rb. Yep, right there. And then just search for TTIN.
Oh. Okay. Signal trap. Each of the signals are, let's see, where are you?
Yeah, so the actual implementation is down a little bit. There should be a hash with signal name mapped to right there. Yeah,
a lambda. List each of the threads. Thread backtrace. Oh, that's so easy. So if somebody wanted to do that with their own thing, if they have their list of threads, your thread already has the backtrace attribute or property to it. And that just comes from Ruby itself. That's not even something you had to do at all. So it's just...
Yeah, exactly.
Those are the most fun things when you find out, like, that sounds like a hard problem or a hard thing to implement. Like, how do I get the backtrace and whatever? Because normally we probably only just send our backtrace over to Honey Badger or whatever and just let them take care of it or whatever. And not often you're writing code that interacts with the backtrace, at least in your applications, but that's it. Nothing to it.
Yeah, I wish more infrastructure would bake in stuff like this so that, to make people's lives easier to debug.
Yeah.
But yeah, it's one of those hidden superpowers of Sidekick. If you know Sidekick, then you can obviously do this kind of stuff out of the box without an issue.
Yeah. And it's cool to see like the sigterm and interrupt are just raise the interrupt, which looks like rescues, stops everything, and that's where you've seen these messages before. But it's such a simple thing where it's like we have a callback listening for any of those things, and then raising that just make sure that it happens, and is handled here by the launcher. And it's like not hard to set those up to make your program actually work with Linux signals like that or OS signals. That's cool.
Yeah, and in fact, if you look at line 139 down there, use the TTIN signal to determine why your sidekick is stuck.
That's awesome. Yeah.
Get another mention of it. It's all right there in front of us the whole time.
Yeah.
Yeah.
And most importantly, the holiday colors, though.
Yeah, that's a little Easter egg that no one has really ever mentioned to me. I put that in for Sidekick 7, and
that's great.
On St. Patrick's Day and Halloween, the belt color of the Sidekick character in the terminal changes color.
That's awesome.
Oh man, that is amazing. Yeah, that's a good pull request to add another color for another fun day.
Yep.
That's great. I love that. And we wouldn't have noticed that had we not been looking for TTIN here.
I mean, who knows what you're going to learn when you read through the code.
Yeah.
Yeah. Yep.
Cool. Yeah. I mean, this looks good to me. Like, this is what I planned on implementing. Once we discovered that there was a loop in close, I did not think that there was going to be a loop in close, and the loop that I called, I assumed was the only loop that we would run into, only to discover, hey, our thread is stuck at this step in production. And here, sure enough, there's another loop that we didn't know about, which means, at least in a situation like this where you've got a network connection and you're waiting for stuff indefinitely, then you definitely want to implement a timeout as part of that, just so that you can control that it ends at some point. Because, infinite loops are not ideal. Maybe if you're writing games, but even then.
It's true. Don't use infinite loops, kids.
Yeah, make sure you have a way to get out of them at least. Cool. Well, I don't have anything else that I wanted to cover unless you did.
No, I don't know that we can reproduce this behavior in this video. So
no,
all
but
I can say is maybe let me
up.
know how it goes.
Yeah, we'll have a follow-up, and if it works well, then I feel like this will be a good contribution back to net-ssh to have an example of this built in. But also maybe this is an interesting thing that you could maybe extract out, because it's now going to be used in a couple places, like our loop that we use for running commands, but also close starts to be a thing that there might be other loops in here that we don't know about yet that also could benefit from a timeout. And it would be interesting to, have a way of implementing that or something. So, yeah.
Okay.
Cool. This is fun.
Yeah. Did you want to put that transport close in an ensure block?
No, we could.
Or do you think it's better as is?
Since we determined that this raises and doesn't close already, it seems like a similar situation that if they're not worried about closing it, in that case, it's partially the same disconnect situation here where we just stop listening, and it would have the same side effects in both cases, if there are any. So I don't see that there's a need for it, but it might be better as an implementation to do that.
I mean, I would think I would probably want to put an ensure block there.
Yeah.
But not knowing that library any better, I don't want to leak anything locally.
Yeah.
Even if the remote side is misbehaving, you still want to clean up locally, and I think the ensure block ensures that.
Yeah. And that is often probably a place too where it's like, hopefully you can chat with the author of the library and discuss those things because they should have more deep knowledge about what transport close does and if this really should be in an insure block or not.
Yeah.
So makes sense.
Okay.
Cool.
Well,
I
we'll
like
run
it.
this in production and let me know how it goes.
Yeah, we'll follow back up. So that sounds good.